Hello, folks. Welcome back. I did this in class today, and so I wanted to make a short video and hopefully do it with you. Conditionals and related statements. Let me share my screen, and let me get this over here. There we go. All right, so conditionals. A conditional statement has usually an if statement and then a then statement that follows after it. Sometimes they can be worded a bit differently. You won't always see the if and then the then, but the conditional says if one thing is true, then something else would be true as well. So the example that I was using in class is this one. If it rains, then I should have waited a minute to start the video. But it's half past the hour. If it rains, then my car is wet. And of course, I parked outside, and so yes, that's true. If it rains, then my car is wet. You can put any declarative statement in there that you want to. Like, if the sky is blue, then I'm in a happy mood, or whatever. The thing that you put after the if statement is called the hypothesis. And the thing that you put after the then statement is the conclusion. And sometimes in different kind of logics, these have different names, but this is what we're going to work with right now. Okay, the only way that the conditional is a false statement in its entirety, not the individual parts, but in its entirety, is if the hypothesis is true, but the conclusion is false. If that's the case, then the whole thing is a false conditional. So I think today in class I said, if you study, then you always get an A. And they were like, oh no, like that's not true. And I said, okay, then the conditional is false. The thing that trips them up is this, that if the hypothesis is false, it doesn't matter what the conclusion is. It's a true conditional. I think we had one in class that said something like, if 1 plus 1 equals 3, then dogs are reptiles. And the kids were all saying, that's a false conditional. No, that's a true conditional. The only way the entire conditional would be false is if the first part's true and the second part, the conclusion, is not necessarily true. So if 1 plus 1 is equal to 3, then it doesn't matter what you say right there. That could be any stupid thing in the world. If this is false, if the hypothesis is false, then whatever. Okay? So there's 3 related statements now to this. So let me clean this up a little bit because I'm just going to duplicate. I'm just going to copy. Let me see if I can do a little iPad teacher trick. Oh, I can. Check me out. I can duplicate it. And I'll duplicate it again, and I'll duplicate it one more time. Right. Sometimes I just love the iPad. All right, I'm going to put this one down here. Let me grab this one then. Come on, grab that one. Oh, no, I had to do it. Rats. Sometimes it doesn't go as planned. I'll have to move each one of them one at a time. Okay, so let me grab that one and pull it down. I just said teacher trick, and then it didn't work. I'm going to move that one down. I love my job. All right, move that one down. Okay, so if it rains, then my car is wet. Let me do this. Let me take the conclusion and swap it with the hypothesis. If my car is wet, then it rains. That's a different statement. This statement actually has its own special name. This is called the converse. When you switch the hypothesis and the conclusion, you get a converse. Now, even if the original conditional is true, there's no guarantee that the converse is also true. It's a separate statement. You have to think about that. One of the exercises we had was, if it's Friday, then it must be, it was something like August 31st, 2012. No, that's not a true hypothesis. Just because it's Friday doesn't mean it must be a particular date. But then when we switch them around, if it's August 31st, 2012, then it's a Friday. Well, that won't happen to be true. You have to take each one of these statements on their own account, except for the last one. The last one is kind of special. Okay, so if you switch the hypothesis and the conclusion, it's called the converse. Now, this next one here, which is still a copy of the original. If it rains, then my car is wet. If you take the negative of both of those statements, if it does not rain, then my car is not wet, then that's called the inverse. You have to negate both of the statements. And if your statement has a not in it, then you change it to is. Don't make it a not. That's kind of weird. It's like in math, two negatives make an affirmative. Don't leave it as two negatives. Don't subtract a -5. Add 5, right? Change it to a plus. And again, the inverse statement is not necessarily true, even if the original one is. Even if it's true that if it rains, then my car is wet, just because it doesn't rain doesn't mean my car is not wet. There may be another reason why it may be wet, like the sprinklers may have come on or something. Or the freshman had a water balloon fight around my car and it got hit with a water balloon and then it's wet or something like that. So if you negate both of them, it's called an inverse. Now, the last one's kind of unique. If it rains, then my car is wet. There's the original. If you switch both the hypothesis and the conclusion, that's the converse. But now let me also negate both. If my car is not wet, then it, maybe in this case, did not rain. This is called the contra positive. And it actually is true if the original is true. If it's true that if it rains, then my car, if it rains, then my car is wet. It must also be true that if my car isn't wet, it could not have rained. Remember that logic is about what is known for certain, not about what might possibly be. So the inverse and the converse are maybe possibilities, but not necessities. But if it's true that if it rains, then my car is wet, if that's a true conditional, then the contrapositive is a second statement that also must be true. And if the original statement's false, if it's a false one, then like this one will be false too. So another example I would give would be this one. If I hit my thumb with a hammer, then my thumb is not okay. You probably would say, yeah, that's a true conditional. The contrapositive is also true. Switch them. If my thumb, what's the opposite of is not okay? Or what's the negation of is not okay? Is okay. Then what's the negation of the original hypothesis? I did not hit it with a hammer. Good. Now, for those of you watching the video, I'm going to give you a little extra. Sometimes these things are very difficult to do when you're doing them with statements that you think about, like hitting your thumb with a hammer and is your thumb okay? Are you okay? Are you okay, my thumb? No, you've been struck by a smooth criminal. But if we can put these in symbolic form, it actually might be a little easier. If P just is some statement, it's like a variable. If P, then some other statement. Q is the conclusion. I can write that in symbols. P leads to or implies Q. There's our first conditional. If P, then Q. The converse would look like this. If Q, then P. Converse. The inverse would be the negation of both P and Q, but they stay in their original spots. Not P, the little squiggly line, it means not in logic. Not P, therefore, whoops, I forgot the not. Not Q, that's the inverse. Okay, and now the big one. Switch them and negate them. Not Q implies not P. That's the contrapositive. So you're like, holy smokes, we used variable in algebra and that messed me all up. Now you're doing variables to represent language statements? Yes, I am. And it actually is helpful because it helps you see the relationship between the statements and not get so distracted on the statements themselves. That's confusing. It takes your mind off the structure of the statements. Kids are like, ow, like how hard did you hit it with a hammer? And like, I don't know, did you break your bone? You're gonna lose your finger. Like, okay, you don't want to focus on the details of the statement. You want to focus on the logical connections between the statements. So, anyway, there you go. What would be a good final, oh, I know, a good final conditional statement. If you don't eat your meat, you can't have any pudding. How can you have any pudding if you don't eat your meat?